In previous video, we have understood 2-degree alcohol oxidation mechanism by KMnO4. Here we have 3-degree alcohol. But please check, for 3-degree alcohol, dilute sulfuric acid will not work. We require concentrated sulfuric acid. The topic is not involved in 12th class, but for JEE Advanced and B.Sc, it is there. Let's try to understand. As you know, 3-degree alcohol on reacting with KMnO4 in concentrated sulfuric acid, firstly will show dehydration. Due to dehydration, alkenes will generate, and these alkenes will further oxidize to ketones or aldehydes depending on their nature. Now from here to here, the mechanism part already we have done. Under the topic of 3-degree alcohol dehydration. When we have done dehydration reactions of alcohol, there we have done 1-degree alcohol dehydration, 2-degree alcohol dehydration, 3-degree alcohol dehydration. So that mechanism already we know. So let's start. Suppose we have this 3-degree alcohol. What will happen when it will react with KMnO4 and concentrated sulfuric acid? Firstly, there is a role of concentrated sulfuric acid which will provide H positive particles. These H positive particles are electrophile, wants electron, who can provide oxygen, due to which the next particle generated will be this. We call it protonated alcohol because alcohol is getting proton. Now oxygen will carry a +1 charge because it is making a dative bond, obviously unstable, will break bond from carbon. Carbocation will generate, that I am rubbing directly here. This one. Now these carbocations can be stabilized by neighboring carbon, alpha carbon. How? By shifting these electrons here. Double bond will generate and alkene will generate. Now here we have 3 type of alpha carbons, 1, 2 and 3. Which alpha carbon will create major alkene, most stable alkene? That will be this one. It will shift electron here and between them double bond will generate and alkene generated will be this. I am going to draw a major alkene. Other alkenes will also generate, but they will be minor alkene. Reason we have already discussed, hyperconjugation. More stable alkene, it will be a major. So that is most stable alkene out of these 3. So that's why this I will use for further oxidation. This is my major alkene. Up to here we have already done and the dehydration of alcohol, so no need to discuss too much about it. So directly I am going to use this alkene for oxidation. Now check what will happen. This is the alkene which is generated. Here we have KMnO4, which is providing us MnO4 negative particle. We know its nature very well. In previous videos, we have discussed many a time. Mn is making 7 covalent bonds with oxygen, means 7 electrons it is sharing with oxygens, and oxygens are highly electronegative. They are attracting 7 electrons. That's why this Mn is carrying +7 charge. Due to this +7 charge, it has a tendency to gain electrons, means it is working as an electrophile. Who can provide electrons to it? Yes, alkenes are ready. In alkenes, pi electrons are available. That's it. pi electrons will go toward Mn, but not directly, indirectly. In previous video also we have done this mechanism. How? This oxygen will go closer toward carbon, due to which these pi electrons will come toward oxygen and these pi electrons will shift toward manganese. Indirectly, magnesium is getting electron. Manganese is getting electrons. Sorry, I said magnesium. Manganese is getting electron. Now when this will happen, because this carbon has lost its electron, so what will generate? Positive charge. This carbon will make single bond with oxygen. Now between this manganese and oxygen bond will break, only single bond will left, and these electrons will go on manganese, rest part as it is. Positive carbon, oxygen. In previous video I also told you what to do. Pi electrons are there, will satisfy vacant orbital. So between this carbon and this oxygen, bond will generate, date a bond like this, and this +1 charge will finish out. What is that? This is cyclic manganese diester. This one. In hot conditions and highly acidic medium, what will happen? This cyclic manganese diester, you can check, it's a crowded cycle, due to which there is a pressure on this bond and this bond is getting weaker. So it will start to break. How? Like this. Suppose this carbon will provide both electrons toward this oxygen, due to which manganese oxygen bond will break and they will shift toward manganese, because the oxygen is getting electron from carbon side, and this carbon will become positive, so this oxygen will provide electrons for its satisfaction like this. So what will be the compounds generated here? Let's check. Double bond will come between carbon and oxygen. Here double bond will come between this carbon and oxygen. That's it. You can check. Two ketones are, sorry, this is two aldehyde. Two aldehydes are generated there. Two aldehydes are generated. And what oxidation state of Mn will be here? Try by yourself. Count number of electrons coming and how many electrons are going, and check that oxidation of Mn. This is a mechanism. Now here two aldehydes are generated. Depending on type of alkene, ketones can also be generated. Different aldehydes can generate. Two ketones can be generated. Now what will happen with these aldehydes? We know these aldehydes can also further can be oxidized by KMnO4. So these aldehydes will further oxidized by KMnO4, and you know when aldehydes will oxidized, they will create carboxylic acids. Mechanism we know. Already we have discussed the mechanism. Please check the previous videos. That's it. This is the end of the video. In this fashion, 3-degree alcohols get oxidation through KMnO4, first dehydration and then alkene generation, and that alkene will further oxidized through cyclic manganese diester intermediate, which is a crowded and cyclic. That's why between carbon bond will become weak. And note down, it is not necessary that in this fashion you will break bond. It's your choice. You want to break it in this fashion, or you can break it like that also. Same compounds will generate. Suppose you want to transfer electron to this oxygen in opposite direction, bonds will break like this. Compounds will be same compounds will generate, same oxidation of Mn will change. Please check change in oxidation state of Mn by yourself. Thank you very much for watching the video.